Welcome students to our word problem Redux video, and Redux just means we bring it back up again. This is one of my favorite memes. Go ahead and have a read if you haven't read it yet. It's kind of hilarious, and I know that's how some of you feel about word problems, and I totally get that. That's okay to feel that way about word problems. But anyway, let's go ahead and actually jump in and do several. So these are the different types we've done so far. We're reviewing, and you might have one or two that look a little bit new. We're going to start with an age word problem. All right, Elise is 4 times as old as Amanda. In 10 years, Amanda's age will be half of Elise's. How old are they now? So the first thing we need to do is write out our unknowns. And what are our unknowns? They are Elise now, Amanda now, Elise in 10 years, and Amanda in 10 years. All right, Elise is 4 times as old as Amanda. So again, we want to look at which one do we know the least about. We know the least about Amanda. So we're going to have A represent Amanda's age now. Elise is 4 times as old as she is. So how do we represent Elise's age now? 4A, 4 times as old as Amanda. In 10 years, so stop. Before you start looking at the rest of this sentence, which that's for our equation. Okay, that's going to be for our equation. First, represent Elise's age in 10 years and Amanda's age in 10 years. Well, if Elise is 4A now, in 10 years she'll be 10 more than 4A. If Amanda's A now, in 10 years she'll be 10 more than A. Now I'm going to look at the rest of that equation. Amanda's age, that in 10 years, Amanda's age will be half of Elise's. So Amanda's age in 10 years will be, as my equals sign, half of Elise's age in 10 years. And there we go. And this is a nice one with the fraction because when I distribute, my fraction will be gone. And this is an easier problem to solve at that point. So I can subtract A from each side, giving me 10 equals A plus 5. Easy peasy, subtract 5 from each side, A equals 5. So to answer the question, Amanda is how old? Well, Amanda now is A, which is 5 years old. And Elise would be, it's right here, 4 times A, 4 times 5, 20 years old. Okay, and I violated my own rule. I was supposed to put these in the form of a sentence, so I'm going to erase my equal sign and write the word is. The abbreviations are fine. All right, that's an age word problem. Let's do the next one. Okay, this one is rate times time equals distance. So before I even start, I know I'm going to need one of these R times T equals D. And I know I'm going to need some sort of table. Whoops, I didn't mean to put that there. I need some sort of table for this. Sorry, I had to fix it. 2 cars leave from the same place at the same time and travel in opposite directions. One car travels at 55 miles per hour and the other at 75. After how many hours will they be 520 miles apart? Well, we already know the distance now. That's 520 miles. So I'm going to put that in the distance column. For the rate and the time column, however, we have it separated. One car's going 55 miles an hour. The other one's going 75 miles an hour. They're both traveling. They leave at the same time, and they travel for the same amount of time. We don't know what that time is, so we're going to call it T. And we've learned that rate times time, you see it right here, rate times time is equal to distance. So I can represent the distances they have traveled individually by multiplying. 55 times T, or 55T for one of them, 75 times T, or 75T for the other. The total is 520 miles. So how can I put that into an equation? Well, if the first car, the slower car, traveled a distance of 55T, and the faster car traveled a distance of 75T, those two distances together add up to 520. And when we solve that equation, we're going to add them. 55 and 75 is 130. So 130T equals 520. I can solve that, dividing by 130. Oop, 30, there we go. T equals 4. So after how many hours will they be 520 miles apart? 4 hours. Okay, after 4 hours, they will be 520 miles apart. Awesome, next. Now we have a consecutive integer problem. Find three consecutive integers such that the sum of the first two is 3 times the third. So some consecutive integer problems ask you about consecutive even or odd. This is just consecutive integers. The other type, also some consecutive integer problems ask you about or tell you the sum of the three numbers or the sum of however many numbers it is. But in this case, we're going to have the sum of the first two is 3 times the third. So let's list them. The first of the three consecutive integers is always x. The second one more than that. And the third one is one more even than that. So x, x plus 1, and x plus 2 are the three integers. The sum of the first two is equal to 3 times the third. So we're going to add the first two together, and on the other side we're going to have 3 times the third. The sum of the first two is equal to 3 times the third. Combine your like terms and solve. This is a great opportunity to pause it and solve it for yourself. I'm going to do the same thing in a moment, so the answer is just going to pop up on the screen in just a minute. But do it for yourself first, so pause your video and try. Okay, and here it comes. Bam, x is -5. Now remember, they're integers. Integers are your number line numbers. So that's your numbers that you would write on a number line. Positive whole numbers and negative whole numbers. So it's okay that it's a negative. And think carefully about how you're going to actually find what those three integers are. Okay, so the integers are, we have the first one, -5. The next one is -5 plus 1. -5 plus 1 is -4. And the third one is -5 plus 2, which is -3. So the integers are -5, -4, let's change that to an and instead of a comma, and -3. Fabulous. Just a couple more. Ratios and proportions. We haven't done many of these. This is one of the ones in your notebook. So we're getting one of them done. So when you go to do the classwork, this is one of the ones actually in your notebook. The Shirley Temple drink is made with a ratio of 8 parts of ginger ale to 1, that should be part grenadine. Let me fix that. 1 part grenadine syrup. How much of each is needed to make a 12-ounce Shirley Temple? Okay, so first we're going to represent the two amounts that we have. We have how much ginger ale we have. Ginger ale. Okay, we're going to represent the amount of ginger ale, and we're going to represent the amount of grenadine. If you have 12 ounces total, if you have X ounces of ginger ale, how many ounces of grenadine do you have? Well, that would be 12 minus X. 12 minus X, because if it's 12 total, you have the whole thing minus how much ginger ale you have. So it's whatever's left, okay, of those 12 ounces. Now we can write a proportion. It's 8 parts ginger ale to 1 part grenadine. We're going to put the ginger ale expression on the top and the grenadine expression on the bottom. Okay, so we cross multiply to solve. 1 times x, 8x. 1 times x, 8x. Come on, Miss LeCompte. What was that? That was pitiful. Let's try that again. 1 times x, x. Duh. And 8 times 12 minus x. So we distribute. So that's 96 minus 8x equals x. We're going to add 8x to each side, giving me 9x equals 96. So it's not going to come out to a whole number, and that's okay. It's 10 2/3. Okay, so we now know that the amount of ginger ale, is 10 2/3 ounces. How much is left to be grenadine? How much is left to be grenadine? So in other words, 12 minus 10 2/3. 12 minus 10 2/3 is 1 1/3. So 1 1/3 ounce grenadine. Not sure how you would measure that if you were working in a restaurant, but that's okay. Onward to the next type of problem. Okay, working on commission. We saw one like this on the benchmark, so I made one up nicely real quick here. Phil works on commission selling electronics. He makes $250 plus 8% of his sales each week. How much must Phil sell in order to earn $400 next week? Okay, so our unknown value is exactly what it asks for in the problem. And that is X, the amount Phil must sell. So his total sales for the week, what they have to be. So Phil makes 8% of his sales plus $250, and he's trying to earn $400. So the right-hand side of my equation is going to be 400, and on the left-hand side, we know he already makes $250. how do I express 8% of his sales if his sales would be X? X is the amount that he has to sell, or in other words, Phil's sales for the week. Okay, so how do I express 8% of that? Well, 8% is cents. So what's the decimal form? That's right, 0.08. So 0.08x. All right, to solve that, we're going to subtract 250 from each side, giving me 0.08x equals 150. We're going to divide by 800, 0.08. Remember that when you're dividing a whole number by a decimal, you get a larger answer. So don't think that this is a bizarre answer. 1,875. Okay, so Phil's sales, Phil must sell $1,875 worth of electronics. Excellent. All right, 2 more. A direct or inverse variation. We have these on the previous video, so I want you to do the same thing we did before with an earlier problem. I want you to pause it. I want you to try this. Use your notes from the previous video if you need to. But I'm going to go ahead and, in a moment, write it all the way out and go over it instead of writing it out for you. So pause it, try it, come back and see my answer. Okay, here it comes. And there it is. Okay, the time to complete a project varies inversely with the number of employees. So, excuse me, T for time in days, N for number of employees. In number of employees. We don't really need a unit for that because it's just a number of people. So, because it tells me time varies inversely with number of employees, I can write that equation. Time varies inversely is K over number of employees. Plug in the pair they gave us, which is 3 people, 7 days. Find K. So we plug in the 3 for N and the 7 for T, and we solve for K. K is 21. So the constant in this is always 21. So this formula is going to fit any pair of values in this problem. So if I know how many employees, I can always find the time. So plug in the number of employees they want us to use, which is 5. Simplify down. 21 over 5 is 4 1/5. 4 1/5 days to complete the project. All right, last one. I bet you can guess what it is. Yes, that's right. It's a direct variation problem. Read it, pause it, try it. I'm going to go ahead and write it out in a moment, and then I'll go over it for you. Okay, here it comes. Ta-da! Okay, the number of bricks laid varies directly with the amount of time spent. Well, that makes sense. The more time you spend laying bricks, the more bricks get laid. N is going to represent number of bricks. T is going to represent time, in minutes this time. So, the number of bricks varies directly with the time. So notice how the equation is set up. Plug in the values they gave us, 45 bricks in 65 minutes. Divide to find K, and we end up with a K value of 9/13. So that should say 9/13 equals K. I forgot about that part. Okay? Plug it back in. So N equals 9/13 T. Plug in the 500 for number of bricks and solve. And by I solved here by multiplying by 13/9 on both sides. 6,500 over 9, when I divide, is 722.2 repeating, so about 722 minutes, or about 12.04 hours to lay that many bricks. That's a long day of bricklaying. That takes care of 8 different types of 8? Did I say 8? Was it 6? Well, I had 8 slides, so 7 different types of word problems. Oh, that's right, I had the Roman numeral 6 for both direct or inverse. Good. Okay, so that's Word Problems Redux. Come to class for our next class prepared to solve a whole bunch of word problems and to go over some more direct and inverse variation material. Thanks, guys. I will, switch so I can actually see it. I will see you in class.